Welcome to Artec. Today I'm going to teach you how to program a Lynx Smart BMS in relation to Victron Smart Lithium batteries. The first step is going to be opening up Victron Connect on either Android or iOS. When we open up Victron Connect, it's going to present me with my devices, both local and on VRM. In this case, I'm going to select the Garmin Bench BMS, as this is the BMS in our test bench. Now that I've selected the Lynx BMS, it's going to take me to the product homepage. In this case, on the top right hand corner, I can see the settings cog and I'm going to select that. Now that I'm in the settings page, I'm going to change the settings specific to our system. First up with system settings. The very first one is to confirm the battery bank voltage. In our case, we have a 12 volt system. I'm then going to change the battery bank capacity, which in our case, we have a 50 amp hour battery bank. It's then going to ask me the number of batteries that are in parallel. In our case, we only have a single battery. If you had 2, 3, 4 batteries here, this is where you would change that. When you go to a 48 volt system, it's important to remember that each series battery counts as one. So if you have two 24 volt 200 amp hour batteries ran in series, that's one battery in parallel. Next, we're going to go over the BMS settings, pre-alarm. In our system, we leave this disabled. The next section is relay settings, specifically relay mode. For our system, we're testing wake speed units, and hence we're going to set this to alternator ATC. If you had a wake speed in here, you would set this to alternator ATC. If you did not have a wake speed in here, you would select this to alarm relay. The next section is DVCC settings. In our case, we leave these as factory. Beneath DVCC settings, there's the battery monitor settings. We're going to leave the next 3 settings the same, which is going to be charge voltage at 14 volts, tail current at 4%, and charge detection time at 3 minutes. However, the low SOC warning level is going to come from factory at 15%, I like setting this to 25%, and the discharge floor is going to come from factory at 10%, I like setting this to 20%. By increasing these, it's going to give you more of a buffer to recover your system from a low voltage event, using easier methods, such as plugging in your inverter charger. The next section is going to be state of charge. I never set this manually, I always let the shunt calibrate this through a full charge cycle. The final setting in here is going to be to configure the Lynx distributor's settings. In this case, we have a single Lynx distributor in our system and hence it's presented as distributor A. I'm going to select that and it's going to take me into the sub-settings. This is going to allow me to turn on and off fuse monitoring to the 4 fuses within that Lynx distributor. I'm going to select fuse number 1 and activate it. This is going to give me an opportunity to name this fuse. Typically, we're going to name it as to what it's protecting. So in this case, I'm going to select and name it inverter. We also recommend putting the fuse size in here so that end users have this information if that fuse was to blow. In this case, for a Multiplus 3000 12 volt, I'm going to select 400. Because we don't have a fuse in our test system for position 1, it's showing up as a fuse blown indicator. Thanks for following along today as I teach you how to configure a Lynx BMS and the distributor associated. If you have any questions, please reach out to our staff. As always, I'll leave all of the applicable links in the description below.